All right, good morning and welcome to this solution and explanation from NCERT. The chapter is thermodynamics, and the topic we are focusing on is the refrigerator. If you see this numerical, it is focused on refrigerator. Now let's talk about refrigerator. What is a refrigerator? Okay, so refrigerator is basically a mechanism in which what you do is it's, for example, this is your refrigerator. Okay, this is your refrigerator. What you do is you work on this refrigerator. Okay, work has to be done on the refrigerator. You work on the refrigerator. There is a low temperature reservoir in the refrigerator. So there is a low temperature TL. So this is a low temperature reservoir, right? This work done extracts, okay, I will just draw the reservoir. This work done extracts heat from this low temperature reservoir. This heat is called as Q low. And then this heat is thrown to a high temperature reservoir, okay, which is your environment, which is the room in which the refrigerator is kept. This is called as QH. You can feel the heat. So what is a refrigerator? The refrigerator is a system on which work is done. This work done extracts heat from a low temperature reservoir. This is the heat of the low temperature reservoir which has been extracted, and then the heat is thrown in a high temperature reservoir. This is the heat being referred to. If you just try to link W, QH and QL using the first law of thermodynamics, the first law of thermodynamics, how will you apply this now that you understand the basics of a refrigerator? At least you have a sense what's happening. A system on which the work is applied. The work is used to extract heat from the low temperature reservoir, and this heat is then thrown to the high temperature reservoir in the form of QH. So the work done as per the first law is given by QH minus QL, right? This is the way the reservoir works. Now, what is the coefficient of performance? How do you know your refrigerator is working nicely? There is a term called as coefficient of performance. You can see the word. You are talking about performance. What is performance of anything? You are spending money. Where are you spending money? Electricity. The work you're doing is electricity. This is the money you are spending. And what you want? You want extraction of heat, right? You want extraction of heat. So how much heat has been extracted? That's your coefficient of performance, right? So I will just write COP. This is what you pay for, right? Electricity, you pay for this. What you want is in the numerator, right? That's your performance. For every joule you spend, how much heat you're able to extract out of the system. That is what you are trying to calculate, right? So this is QL. Make sense? You want heat to be extracted to cool the low temperature reservoir objects. This is your final aim. If you're successful in removing more and more heat from the low temperature reservoir, that's success. This is what you want. This is success. This is what you want. extraction of heat from low temperature reservoir. What is that you want? That's a numerator, right? So if I were to write what we want, extraction of heat from low temperature reservoir. How do we achieve it? By spending money, by doing some work. That's your coefficient of performance, right? This is also in joules. The money you spend, what you want, removal of heat. This is also in joules. So there is no units for COP. It's a ratio. It's a ratio. Now let's talk about what? Let's talk about the numerical, right? We have linked everything. We have linked whatever we could. I will just convert all of this into a formula. We will not do derivation today of coefficient of performance. Currently, the coefficient of performance has been linked to the heat which you're extracting from the low temperature reservoir and the work done. What I will do is I will convert this formula into temperature of the high uh, temperature reservoir, which is this one where you extract the heat and throw the heat by doing the work. We wrote this equation, right, which is the first law of thermodynamics. So we will convert this, the coefficient of performance. All right, so let's come to the mathematical part of this. So the coefficient of performance is given by, right, I told you it's given by QL, which is what you want to achieve, divided by what you pay for. Let's convert this into QL divided by, from the first law of thermodynamics, QH minus QL. And then I told you we will not do derivation. Let me convert this into the temperature of this reservoir, which is a low temperature reservoir, divided by the difference of temperature between the two reservoirs. If you go to your numerical, let's see what all is given. You're given TL, always convert it into Kelvin, right? So your TL in the numerical is 273 plus 9. Remember, the low temperature is given like this, right? It's given in a refrigerator, kept inside 9 degrees. The lower reservoir is inside the refrigerator, 9 degrees, the low part of it, right? So 273 plus 9. The high temperature where you want to throw the heat, which is QH, to be thrown in the room. Look into the question, the room temperature, right? So this is room temperature, 36 degrees, is equal to 273 plus 36. The coefficient of performance, let's calculate it, is equal to 273 plus 9 divided by 273 plus 36 minus 273 minus 9 is equal to 273. So this is going to be 282 divided by 20, 36 minus 9, right? 27. So approximately 270, and then another 12, approximately 10.7. This is your answer of coefficient of performance. How will you memorize this? Again, this is the trick. What is that you want? You want the heat to be extracted from the low temperature reservoir. And how do you achieve it? By paying for it using electricity. So QL is in the numerator, and similarly the low reservoir temperature is in the numerator. The work done has been found using this particular expression, which is the first law of thermodynamics. I have not gone into the derivation. Therefore, just take it with a pinch of salt. Just apply it directly. So TH minus TL. Remember this formula very carefully. Always convert centigrade into Kelvin. Otherwise, you will not be able to solve this. Always show this working, right? I hope this made sense to you. My channel has 2000 videos explained. This is the only channel which is emphasizing explanation. Without explanation, you will not be able to learn anything. If you see my questions, the logic will stay with you for your life. You will never forget it. Always go for explanation if you want to build strong career base. Thank you very much for your time. Wait for my next video.